Hi, this is Mr. Anderson, and today I'm going to show you how to draw a Lewis dot diagram. Lewis dot diagrams are going to look like this. So if we start with cesium, cesium is a metal. It's got an atomic number of 55, but it's in the first column, and so that makes it really easy on the periodic table. That means it has one valence electron. So if I had to draw its Lewis dot diagram, it would look like this. You're going to have Cs for the atomic symbol of cesium, and then you're going to have one dot, and that represents one valence electron. Now that one valence electron makes it really, really reactive. And so if you mix cesium with water, let's take a look at this video.
Let's try cesium, our fifth alkali metal.
You get a huge explosion, and the reason you get that huge explosion is due to that one valence electron. So by the end of this video, you should be able to draw Lewis dot diagrams, and you also should be able to draw Lewis dot diagrams for molecules. In other words, when you mix cesium with water, you're going to make cesium hydroxide, you're going to make hydrogen gas, and so we should be able to draw those Lewis dot structures for molecules as well. So let's get started. If we look on the periodic table, the first thing you want to, and you'll keep jumping back to the periodic table over and over and over again, so just get used to that. So if we look at it, the first thing that jumps out is that there are this verticality. In other words, all of these alkali metals right here have the same properties, and that's because they all have one valence electron. And so learn this right away, that there are one valence electron in the first column, two valence in the next one. So this would be 3 and 4 and 5 and 6 and 7 and 8. So all of these, you probably know this, these are called the noble gases, are very stable, and that's because they have 8 valence electrons. Whereas these alkali metals and these halogens right here are incredibly unstable, and then we have kind of a combination in the middle. What you just noticed is that I ignored all of these, the transition metals, and their electron configurations are a little more complex. But please learn this right away. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. You can't do Lewis dot diagrams unless you know how many valence electrons they have. So let's start with the first one. This is my method. I can't remember where I picked this up, but first thing I do is in my brain, I draw crosshairs across the symbol. So we're going to do neon. Let's jump back again to the periodic table. Where's neon? Neon's going to be way over here. Here's neon. And so it's going to have how many valence electrons? 8. So let's do the biggest one right away. 8 valence electrons. So again, I've drawn this in my head. I have this crosshair. So I'm just going to start putting in electrons like this. So here's 1 valence electron, 7 to go. Here's 2, 3, 4. Now it doesn't matter if I start on the top or if I start on the right or the bottom, it doesn't matter. But once I choose a place to start, I have to either go clockwise or counterclockwise and keep going from there. So let's go again. 1, 2, 3, 4. Now I got to put 5 right here. This is 6. This is 7. And then this is going to be 8. So the Lewis dot diagram for neon is going to put, we could just do these all in right here. It's going to look just like that. So neon's really, really happy. It's a stable gas. Let's go to the next one, hydrogen. Hydrogen, you should know, has 1 valence electron. So where's that going to go? Right here. Now I put hydrogen and helium at the top because their rules are a little bit different. Because remember, the periodic table looks the way it does because these first two elements, hydrogen and helium, can only have 2 valence electrons in that outer energy level. So let's go to hydrogen. Hydrogen's going to have 1 of the electrons in its outer energy level. But helium, instead of going around clockwise, it can only have 2 in that outer level. And so this would be the correct Lewis dot structure for that. Let's go do some more. So silicon is going to have 4 valence electrons. If you don't know, you just check on the periodic table. So it's going to have 1, 2, 3, and 4. Or lithium only has 1. So it's going to have one valence electron or 1 Lewis dot. Let's go to carbon. Carbon is the same group as silicon, so it's going to have 4 as well. If we're doing oxygen, how many does oxygen have? Oxygen has 6 valence electrons, and so if I had to draw that, again, imagining those crosshairs in my brain, 1, 2, 3, 4, then here's the 5th, and then here's the 6th. So how many electrons would it like to pick up? 2 more. Or if we go to nitrogen, nitrogen has 5 valence electrons, so 1, 2, 3, 4, 5. Okay, so what are the 2 rules? Again, the 2 rules are, number 1, choose a side. Do you start on the top or do you start? Doesn't matter. But once you start, you're either going to go clockwise or counterclockwise, and you're always going to fill in one valence electron at a time until you come back again. Then you're going to fill those other ones in. So that's how you do atoms, and that's pretty easy. Let's start doing molecules, though. So let's say we take something like hydrogen gas, H2. The way I do it is I first of all draw my Lewis dot structures for each of the atoms. So that'd be one hydrogen. And then here's the other hydrogen. And now I kind of imagine this thing in my brain. How am I going to get this electron and this electron to match up? Well, if you think about it, if I were to rotate this and I were to rotate this, let's do that over here. So if I rotate that one electron over here so it's facing the hydrogen, it would look like that. If I rotate the other hydrogen this way, then it's going to share its electron here. Sometimes if it's too confusing which dot comes from where, you could, instead of using a dot for this one, we could use an X to represent this electron. So now I could rotate this one, and then I'd have an X right here. Now I'm not done yet, because we never draw just two electrons like that in a Lewis structure. We want to show that there's an actual bond or they're sharing those electrons. So I draw a hydrogen with a horizontal line to another hydrogen. So this would be the Lewis structure for H2, or hydrogen gas. This line represents a pair of electrons that the two of them are sharing in a covalent bond. Okay, let's do the next one, H2O. It's going to get a little harder. Let's draw them out. So we've got one hydrogen. It's got one valence electron. We've got another hydrogen with another valence electron. And then we've got an oxygen. Fill that in. It's going to look like that. Okay, so now in my brain I have to figure out how are these going to match up. Well, I can kind of do that. So I'm going to put one here, my oxygen, start with that. I'm going to represent these as X's, my two hydrogens, so you don't get confused. So we've got that, and then we got that. So now let's put our hydrogen in there. So we've got a hydrogen here. There's one, its electron it's sharing. Here's the other hydrogen, and here's its electron it's sharing. So how do we draw the Lewis structure? Let's kind of make this a line then. So we're going to have an oxygen to a hydrogen, and then we're going to have these electron pairs on this side and then on that side as well. So this would be the correct way to draw the Lewis structure for water. And let's do the last one then. So last one's going to be carbon dioxide. Up to this point we've only done single bonds, but let's try and do a double bond. So what do we got here? Two oxygens, one carbon. So let's do the oxygen first. Draw the Lewis structure for that. Then we've got a carbon in the middle. Carbon's going to have 4 valence electrons, so it looks like this. Make that a little nicer. Then we have another oxygen. Oxygen's going to look like that. Okay, now I've got to figure this out. How am I going to rotate this? Well, if you think about this carbon, we could kind of rotate it maybe 45 degrees like that. So I'm going to put the carbon in the middle. And then it's going to share electrons with the oxygen on this side. So these two electrons are going to share with these two electrons over here, and then we're going to form what's called a double bond. Now if I rotate that again, we're going to have our pairs on the side. We got another couple pair that we're sharing to the oxygen, and then we're going to have our electrons around the outside like that. So again, we're not quite done because we want to make sure that those actually are drawn as double bonds. So we'd have a double bond to the oxygen, double bond to the other oxygen. Let's make that actually an O. Then we have our pairs of electrons here on the side, pairs of electrons here on the side. So Lewis dot structures tell us a lot about the valence electrons in an atom, but more importantly, they're going to hint at its chemical structure. Sometimes it's hard to do this in your brain, and you have to get the atom building blocks out, and we can actually do that in class. So I hope that's helpful. Thanks to Mr. Lewis, Gilbert Lewis, we've got these Lewis dot diagrams. The sad story about Mr. Lewis right here, to end on a sad note, is that he did so much work in chemistry, did so much amazing work, really figured out, especially electrons and how electrons work. Sad note is that he was nominated for the Nobel Prize 35 times and he never won. Some scientists think that Gilbert did himself in with a little bit of cyanide in his office after meeting with one of his co-workers who had actually just received a Nobel Prize. So kind of sad, but his legacy, Lewis dot diagram, lives on in chemistry students from here until the end of time. So I hope that's helpful. Thanks.